this video, we're going to review very briefly chemical equations. A reminder that a chemical equation is simply the way that we write out a chemical reaction. A chemical reaction occurs when a substance or substances react with each other, rearrange the atoms, and come out as different compounds. So you start with one or two substances or 50 substances, and you end up with different substances in the end. So we write that out in the form of a chemical equation with chemical formulas, subscripts, coefficients, all of those things. Here we have an example of a chemical equation. This is H2O2 yields H2O plus O2, or if we're talking in normal terms, it is hydrogen peroxide breaks down into water and oxygen. It's important for us to know the names of different parts of a chemical equation. This part on the left, the stuff that goes in, that is called the reactant. It doesn't matter if there are 4 compounds or 1 compound, this is the reactant. We read the arrow as yields, which means makes, and over here we have the product. All of the things that come out of a chemical reaction are called the product. When we look at a chemical equation, it's important for us to also remind ourselves of the law of conservation of mass, which states that you can't gain or lose mass, it just changes its form. So whatever we have on one side of the equation, we're going to have on the other. We're going to have the same elements and the same number of atoms of each of those elements. If that's not the case, then it's considered an unbalanced equation and we have to balance that. So when I look at a chemical equation, the first thing I do is draw a line to divide the reactant from the product, or the left from the right. And then I'm going to make my list of elements. Here we have hydrogen and oxygen on the left, and we're also going to have hydrogen and oxygen on the right, or in the product, because you can't just have some other element show up on one side and not the other. And then I'm going to use the subscript, the small number here, to count the number of atoms. Here I have 2 hydrogens because the subscript tells us how many of the element it follows, how many atoms there are. And here I have a 2 for oxygen. Over here I have hydrogen, also a 2, but here there's no subscript, which is 1, or a ghost 1, some people say. So this 1 and this 2 get added together since oxygen appears in more than one place on the right-hand side. So we have a total of 3 oxygens. Now that doesn't work. This is telling us that we gained an oxygen and we didn't. That's not possible. So we can fix that by changing the coefficient in front of the compounds. The coefficient right now is 1 because there's no number written there. We know that it's a ghost 1, but we can change that to increase numbers and make them match on both sides. So I want to make sure that I get the same number, and this is a tricky one because it's an odd number. I don't want to change over here because I'm still going to end up with an odd number. So I'm going to place a 2 as a coefficient in front of H2O. If it doesn't work, I can go back and erase it and change it to something else. But now what I've done is, because I have this 2 as a coefficient, I now have 2 molecules of water, and that means I've increased my amount of oxygen and hydrogen. I take my coefficient of 2, multiply it by the subscript, and I find that I now have 4 atoms of oxygen. I multiply my coefficient of 2 by my subscript of 1, and I find that I have 2 oxygens here, but remember, we also have the 2 over here, so that's a total of 4 oxygens. Now we have a big mess, but we can come over here and fix this pretty easily. I need to increase the hydrogen on the left and the oxygen. Both of them need to go to 4, and because they're together in this compound, my coefficient of 2 applies to both of those elements in the compound because the coefficient goes with everything. It's the distributive property. So now we're going to take our 2 and multiply it by the subscript 2 and find that we now have 4 hydrogen atoms. And when we multiply our coefficient of 2 by our oxygen's subscript of 2, we find that we have 4 of those as well. And now this is balanced, and that's important. So hopefully that's a good reminder of how we use chemical equations and how we balance them. And now you get to show off what you know.